Thanks everyone for coming out. Hope everyone's having a good QCon, learning a lot, really enjoying yourselves. What I want to do today is do something kind of fun. We're going to talk about two fairly new technologies in the space, those obviously being serverless and GraphQL. We're going to talk about them kind of separately, one at a time, kind of try to understand those, and then talk about putting them together. Because as we all know, nothing ever goes wrong when you take two interesting technologies and putting them together. Microtransactions in AAA console games, for instance, nothing ever goes wrong there. So who am I? I'm Jared Short. I'm the Director of Innovation at Trek10. Trek10 is an AWS Advanced Authorized Consulting Partner, very much a startup. And a few years ago, AWS Lambda came out, and I sat down with a small group of people. We were about 6 people at that point in time. And said, guys, I think we're going to see more in this space. This is a really compelling way of approaching building architectures and software in a way that I don't have to worry about the underlying infrastructure necessarily. So my job at Trek10 is the Director of Innovation. So what that means is really I get to play with all of the bleeding edge stuff, the new shinies out there, and figure out, more importantly, how do I take these new shinies and tame them down and operationalize them and take them back to our clients so they can actually build value with those new tools, utilities, approaches, infrastructure, et cetera. So I've actually been working with serverless in production at production loads across startups and enterprises for about 2 years at this point, hundreds of millions of executions. And we've seen some really interesting and compelling outcomes out of that. So first, I would like to talk about GraphQL. GraphQL is a technology that comes out of Facebook. They've been using it internally since about 2012, and they released it publicly, both the spec and some example implementations in 2015. I don't know how many of you know about some of the Facebook technologies and the patents and licensing issues that were around those. They had an interesting clause that said if you ever sued Facebook, you lost the rights to use any of their stuff in basically any of your products. So people were really scared of it. But recently, Facebook MIT licensed GraphQL and React.js and other technologies that are kind of core to this ecosystem that they're building. And so people have really appreciated that, and they're listening to their community. So what GraphQL is actually a way of modeling your data and your business as somewhat of a graph, and then giving you a standardized query and mutation language and system that you can go and work with this data and your business as a graph. So what it really gives you is essentially one endpoint for your entire API. Unlike a REST-based system, you have not path-based, but just a single endpoint where you can issue your queries and mutations in this standardized pattern, and it gives you back all of the data that you would expect, right? So what this gives you is an easy-to-understand API layer, a single endpoint. All of your aggregated resources can exist behind this endpoint. Your developers only get exactly the data that they're asking for in the shape that they're asking for it. We're going to look at that a little bit later and understand what that really means. You get some streamlined API iteration and extensibility, right? There's really easy ways to keep improving on your API without impacting existing clients or developers. It empowers your clients to easily build more efficient requests across the network. And really, you can abstract away a lot of complexities that you would normally run into when dealing with APIs. And then more importantly, the GraphQL community and tooling is insane. There's so much power behind this that it's hard to ignore. So some technical details of GraphQL. Obviously, there's a schema and a spec, but importantly, it's a typed API, meaning that everything has to be well-defined, similar to a typed programming language or something like that. You have to define all of these things ahead of time, which introduces some interesting capabilities later on further in the stack. So queries, whenever I say query, I essentially mean a read, something that is reading data from the system. When I say mutation, it's obviously something that is writing to the system, causing a data change of some kind. So GraphQL is both this specification for issuing these queries and these mutations, this language, this typed API, and also it's an execution engine that knows how to understand those, and there's reference implementations for Node.js and many other languages. But it's this execution engine that can take these queries and these mutations and figure out how to resolve them for you and provide a pattern to resolve across your data sources and things like that. Also, one really interesting thing is that it elegantly solves the 1+n problem, where typically if you were to list out, say for instance, a list of speakers at QCon, and then you also want to know about the talks, right? So I say, give me all of the speakers in a REST implementation, and I get back all of the speakers, and it might have a list of talk IDs that are related to those speakers, and then I'd have to iterate through each of those speakers, for instance, and say, okay, give me the information about this talk and this talk. So at QCon, there's something like 179 speakers. I would have to do 179 more requests for talks, for instance. With GraphQL, you can elegantly solve that problem. We're going to look at that, actually. So I do have some examples of the schema here, so you can kind of understand it. Like I said, you have to explicitly define all of your types that are going to exist in your API. We have a type of speaker. A speaker has a first name, a last name, has a list of talks. So you can define lists of types, obviously denoted by the brackets there. You can have nullables and non-nullables, meaning that the API is guaranteed to return some data back or doesn't have to guarantee that it will return data back. Scalars, unions, enumerables, inputs. There's all sorts of things you can define in these schemas that make it easier to understand and use later. So if we want to understand this concept of root resolvers. Root resolvers are essentially something that says, at the very beginning of my graph, there has to be an entry point to understand how to change or how to read data from my API. So for instance, the standard approach to this is you have a query root. So for instance, in this case, we have a query root that has two possible things you can ask for. You can either ask for a list of all speakers, or you can ask for a list of all talks. You can pass in arguments or things like that and define these inside of your schema, saying, hey, for speakers, you can pass this in a limit. We might default to some number like 10 or something like that. And you could define that and say, as an argument of when you do these queries, how many speakers you actually want. Or you could do things, for instance, sorts. I want to say I want the talks in ascending order or descending order based on some attribute or field in those. And then both of these are returning back, for instance, list of speakers or the talk type. Mutations are another, I have an instance here. You have a mutation root, and you can take an input type, which can define things like the title of the talk or a list of speaker IDs so that the backend could eventually resolve to the speaker type. And then we pass in that input type. So everything is well defined, which means that we can do really interesting things and provide really interesting tooling for our developers and clients using these systems in GraphQL. This is actually an example, and this is kind of like a reference implementation. We actually have systems in production that look pretty much exactly like this. The top is the query root in GraphQL specification, the schema language. And then the bottom is actually a ripped out chunk of JavaScript that you can look at. And essentially what we do is here, this is demonstrating how light I like to actually keep the GraphQL, the engines themselves when they're actually doing the implementation. So for instance, we ask for, at the query root, a list of speakers. And we have a root, which is essentially looking at what is the thing, the node that potentially called this resolver. We have arguments, we have context. Most of the reference implementations of GraphQL will have some kind of format like this. Context could pass through things like authorization or your users in the system, and then you can propagate those down through the graph tree. So this is a really simple implementation. We have a speaker service, some kind of library or something in our code that is aware of how to go fetch from our data sources these speakers or these talks or things like that. Now, what's more interesting, you'll notice back here we were at the query root. If we want to navigate further down, we have the speaker type, right? So a speaker has a list of talks. And how do we know how to resolve talks for a particular speaker? You can kind of do a very similar thing as we did on the query route. But more importantly, when we look at the root at this point essentially becomes the actual speaker node that has returned back from our data sets, our data resolvers. And we have a list of talk IDs. And so our speaker type says for talks, this is how you resolve a talk field, which we know is a list of talks. And we pass in those talk IDs and load by those. So essentially, you end up modeling your entire GraphQL execution and engine in somewhat of this pattern. But the really important part is that code that I showed is very similar to what we actually do for our GraphQL wrappers in production systems. The important part being that GraphQL is definitely not your business logic layer. We're going to look at some interesting approaches later on where you can wrap various data sources and things like that. But your business logic should not live in your GraphQL engine or in that layer. It should be as thin as possible on top of those other services or those other fetchers of your data and your other business logic. So another really exciting part is that you get just by using GraphQL and that schema definition is the developer and client experience is really quite elegant. Your developers, for instance, if they were asking for the speakers, could simply say, I just want a list of speakers and only their first name. I don't want anything else about them. And that is all that they will ever get back. And it's an elegant way for providing an efficient interface for making those network requests, for traversing that tree down deeper. Also, there's this kind of limited API versioning concerns where I can, as a provider of a GraphQL endpoint, add additional types, add additional nodes, add additional fields for people to be able to query against as my product grows and the demand grows and people have different expectations of the system. I can keep adding on and extending without impacting existing clients in any way. Their request won't change. Now, obviously, you have to be careful. You can't just completely remove a field. You can't change how a field works. But as long as you're being careful about that, you can easily add things without impacting anyone else or sending them a bunch of data that they're not expecting, for instance. API introspection, since this is a completely typed API, it's really easy to essentially introspect on the API and learn about it just by playing with it and issuing essentially kind of like introspection queries against the actual engine itself. So what this actually looks like, there's some tools out there. One's called GraphQL. This is what it looks like. And any GraphQL API that exposes the introspection capabilities can do this, right? So you automatically get, for instance, a documentation explorer built in. You can navigate through and quickly search this because you understand the queries that are possible, the mutations that are possible, all of the types that are possible. You can get autocomplete on the fields for free. I can go point this to practically any GraphQL API, and this stuff will just work. It's actually really incredible and really compelling to have people be able to just like point this kind of utility at your API and just explore it and learn by playing with it. So that's GraphQL. I want to talk about serverless. First of all, I want to apologize for the name serverless. I'm not personally responsible for it, but there's been a lot of complaints. If you ever look on Hacker News, it's hilarious. Like half of it is complaining about how serverless still has servers. So sorry about the name. It's like this massively overloaded term to the point that is getting pretty useless. It's kind of become to mean anything that's that's using functions as a unit of deployment. I really enjoy this. This actually just happened like 2 days ago. Someone released a new serverless platform, and the first thing they do is like, go spin up a server, put the thing on it. You missed the whole point, guys. So more importantly, what serverless kind of means for myself, for our company, for our clients, is that obviously you still run on servers. Everything runs on servers. You just don't care. You don't have to worry about operating system patching. You don't have to worry about the server maintenance. You don't have to worry if this server dies, is my auto-scaling group going to heal or self-heal? You don't have to care about that. You just simply care that I've given my code to somebody. I've told it what kind of events it accepts or what kind of requests it accepts. and they'll handle all of the mapping and scaling and making sure that my code actually responds to those requests. Right? So my responsibility as a developer, or even as an infrastructure ops person, really moves higher up the stack, right? Can I spend more time looking at our code and building better tracing in our code? Can I figure out what our data sources are doing better? I can do that instead of worrying about, is Ubuntu up to date, for instance. And kind of the second core tenet of serverless is billing at the microsecond increments. You never pay for idle, right? So this is, for those game companies out there, this is like micropayments and transactions done right. I want to pay at the 100 millisecond scale, for instance, not at the minute scale or even the hour scale or anything like that. So this pairs really, really well with event-driven models as well. We're not going to talk a whole lot about that today, but if you ever get a chance, really try to dig in and understand, how do I stream events into something like serverless, and why is it so powerful, right? It's this capability of having these massively scalable systems, and you really just don't have to worry about a whole lot of the scaling that you normally would have to. So right, many of those complexities of scaling and availability are absolutely gone. Some other kind of hidden benefits that you start to realize as you build more with serverless infrastructures and start really diving in is that you get these like massive total cost of ownership drops when you aren't worrying about the underlying servers or infrastructure or things like that. When your systems scale simply by what I like to say, just like turning up a dial and saying, I will input more dollars and get out more scale, and without having to do anything else, it really works quite elegantly. We have one client that I can give you an idea for scale that does millions and millions and millions and millions of requests a month, and their compute bill is like $50 a month, and we're storing hundreds of millions of images. So their storage cost is like thousands of dollars a month, and their compute cost is like literally $50. Like, people just don't understand it. If we were trying to run servers to do all of that, it would be way more expensive. So with all of these TCO gains and the economics, you can really focus on the higher value targets in your organization. Your ops teams can say, you know what? How can we take what this service is doing and operationalize it in such a way that we're providing, for instance, a better event stream or data stream to other parts of our business, to other clients in our business? You can focus on those higher value targets. Also, an interesting thing is that you can fail fast and learn things really fast. And when you do that, you can do it for almost free. You can go build a serverless system. A practice I like to do with some of our clients is go and say, hey, what's like something that's really challenging that you have to solve like in the next week that someone's asked you to solve, right? Can we take the next 4 hours and do an MVP of that and launch it and have it working inside of the next 4 hours? And sometimes it works, sometimes it doesn't. But the key is we found out inside of like one business day if we have like a viable approach or if it's totally going to fail. So we fail fast for practically free, and we learn really fast. Let's see here. So some developer hints as you're starting to work on these systems and start looking at serverless. Your functions as a service provider, whether it's Lambda or Azure or Google Compute or anyone, is really irrelevant. Something I've seen recently is that people are starting to complain that don't use Lambda, it's vendor lock-in. Don't use Azure, it's vendor lock-in. You're going to be stuck in their event model. That's not true, right? So you can abstract away whatever they're doing in terms of how they're getting you the events fairly easily. There's actually utilities out there and people out there that kind of provide these wrappers, and you can like scale across these different clouds. Now, what is true and is the case is that people like AWS, people like Microsoft, people like Google are providing other really, really compelling services that tie really closely to their functions as a service, whether it's Lambda or Azure or whatever. And once you start leveraging those particular services, now you have vendor lock-in. That's their plan, right? That's how they're going to get you. That said, for us and our clients, we're totally for it because Amazon obviously builds really fantastic utilities. Azure is coming out with really cool stuff, durable functions with affinity streams and things like that. You can do really cool things, and you just have to evaluate and say, is this platform going to provide more value than I can build myself? If so, tie yourself to it. Functions as a service itself, Lambda, things like that, they're not a vendor lock-in risk, really. All right, so we've talked about serverless, we've talked about GraphQL. What happens when we put these two things together? What does it actually look at? So right off the bat, we can obviously assume that we're going to get all the normal serverless wins, right? We're going to scalability, availability. I don't have to worry about the operating system. I don't have to worry about patching. All of those great benefits. Now, you also get all of the benefits of GraphQL. For instance, clients and the graphical and things like that, and all of that typed API goodness, and those systems, you get all of that as well. Now, what's really cool is that this is very much a 1 + 1 = 3 scenario, where I get something that's actually higher value than just the two components separately, because I can mitigate things like resource exhaustion attacks, which we're going to look at. I can do really complex resolvers and do interesting things based on serverless giving me isolated resources and execution environments. So resource exhaustion attacks is actually something that's fun that I didn't really think about or understand until one day I was like, hey, why is our system not working? Why are these requests hammering our Dynamo table so hard? I thought it was supposed to be serverless, and Dynamo is this magical thing. Why is our system coming to a crawl? Well, resource exhaustion attacks, you can kind of think about them as a denial of service attack that's A, really easy to do against yourself in some circumstances, not good. B, really, really easy for an attacker to hurt you really badly with minimal input from their side. So a resource exhaustion attack is essentially this idea of a really deeply nested request. You can use recursion or things like that, pagination abuse. We're going to look at an example in a little bit. But we're also going to talk about some useful optimization and prevention techniques. So GitHub, I don't know if you've seen their GraphQL API. They actually approach this by enabling pagination and enforcing pagination and limits on any kind of node request. For instance, most types, you have to say, I want up to 100 of this particular node. And they won't give you any more than that. And then you also have to go through the pagination as well. You can do things like maximum depth checking. So if you think about a graph and traversing that graph, you could say, for instance, that anything that has a nested graph of deeper than 5 nests, we're going to throw it out. Obviously, never run it. And then we're also going to look at another just huge performance win, which is request batching and caching. So resource exhaustion attacks, this is kind of what it looks like. So for instance, there's a Star Wars API out there. I don't know if any of you are aware of it. There's a GraphQL wrapper for that Star Wars API. But right here, what we're essentially modeling is the concept of films and characters in Star Wars. So say we want to list out all of the films, and then we want to know all of the characters in each film. That's a pretty simple GraphQL request. This is actually using the relay specification, which you have to have edges in node and relay. You can simplify some of this stuff. Following the relay spec is not a terrible idea. It helps make your request easier. But you can kind of see, if you just look down a couple levels, you see, OK, I have all of the films and all of the characters, right? Now, say someone at your job decides, hey, you know what I actually want? I want to know all of the films that each character is actually into, and I don't know about maps and reduces, so I'm just going to add it to my request here. So I'm going to ask for all of the films for every character. Well, OK, you can do that. It's not great, but eventually it'll still resolve it. We're three levels deep. Now, some enterprising individual, or just mean person, decides, hey, you know what I actually want? I want all of the characters of every film for every character in each of the films of each of the characters, and we're out of memory, right? Our memory can actually get blown up in these requests, especially in a server model. Someone making one of these requests, you can just eat an entire CPU core, eat a ton of memory, especially if you haven't put a lot of thought into how do I protect against this particular attack. So this is an interesting attack model, but when we apply this serverless model, I tend to be somewhat lazy and say, okay, what's like the 80% solution I can get away with? I don't know if this product was going to make it, for instance. I don't want to implement all of these extra protections. I don't want to have to enforce limits or paginations or artificially limit my clients in any way before I need to. So when I apply the serverless model to GraphQL, there's some interesting things I can do, right? So if you look at serverless, the idea is each request is isolated in its own running container or Lambda function or what have you. And since each GraphQL execution, each request goes to its own Lambda function, it gets its own resources, it gets its own 128 megabytes or a gig and a half of memory, its own CPU. I instantly, one, don't have to worry about someone attacking my endpoint and like completely destroying my one server, which now blocks everybody else. They're just destroying one Lambda function, which was theirs assigned to their request, so I don't have to worry about it. And then also, interestingly, the other thing you can do is the infrastructure on most of the functions as a service providers give you this idea of timeouts, right? So instead of even having to look at the maximum depth of a graph, because there might be valid use cases where I have a really deep graph, what I can do instead is say, hey, any request that should normally succeed in, let's say, 5 seconds or 10 seconds, all of my valid requests at the high end are 10 seconds, right? So let's just say, instead of that, all of our requests that are coming into our system, let's just limit and say, if this goes for 15 or 20 seconds, whatever they're doing is probably bad, and we're just going to throw them out of our system. Obviously, you want monitoring and alerting around that kind of thing if that starts becoming more common, but you get an 80% solution for basically one little configuration change in your system. Obviously, in the serverless model, people also like to call it serverful, or serviceful, I should say, not serverful, serviceful, meaning that you should totally leverage other products and services that are out there, like web application firewalls, right? If you can have someone else just handle like a normal DOS attack, lots of IP, lots of people coming and hitting you from a single IP address, certainly throttle those. Like leverage those normal mitigations of those attack vectors. Request batching and caching. This is a little more complex and takes some reasoning about. I do want to point out, so there's this query that we have here where we're saying, give me all of the speakers and give me all of their first names and then give me all of their talks and the title of their talk and then actually give me all of the speakers of each of the talks. So this is totally not an optimal query from the GraphQL standpoint, but it helps us illustrate a couple interesting things if you start thinking about caching and batching. So if we were to just do naive implementation, and for every time we try to run one of these resolvers, thinking back to kind of the beginning when I was talking about the resolvers in GraphQL and kind of those services and resolving by IDs from our data stores, if you had this just strictly naive implementation, and we ran this query where we said, hey, okay, give me a list of all the speakers, and then give me all of the talks and the information for each talk for each of those speakers, and then actually give me each of the speakers for each of those talks that I'm resolving, you end up with something like 359 network requests if you just resolve each of those singularly. So from the front end, the n+1 problem is gone. From the back end, you're absolutely destroying any of your downstream systems. If we implement cache-only approach, which essentially says, all right, I'm going to ask for all of the speakers, and then I'm still going to have to resolve all of the talks because I haven't resolved those yet. But now I'm going to ask for all of the speakers again. If I store each of those speakers from the first time that I requested them, and my system is smart enough, I really only have 132 requests or something like that, because I asked for all of the speakers and then all of the talks. So that's 130 Actually, that's 132, I think. And then when I ask for each of the speakers again, I've already got them cached. I don't have to do more network requests. Batching is where you essentially say, instead of immediately firing every single one of my requests, whenever my system decides it needs to ask for the talk data or for speaker data, you essentially can do things like tap into the node event loop, or in other languages, there's other constructs, and batch up and say, you know what, instead of asking for them individually, I'm going to ask for them all at once at that level. So that actually gets you down to 3 here, 3 requests, because you ask for all of the speakers, and then we batch up and ask for all of the talks, and then we ask for all of the speakers again. Notice we're not caching in this is batch only. We batch up all of the speakers that we need, requests, so we have 3 requests. Now if you implement cache and batching, that's your optimal point, right? We ask for all of the speakers from our systems, we get all of those. We batch and ask for all of the talks in our systems, we get all of those. And then when we ask for all the speakers, which are batched again, we actually have them all existing in cache, so we're down to 2 requests. The important part about this is really, really hard to do. If you ask your developers to do it, they're gonna make a mistake and make things worse. Facebook actually realized this as they were building out GraphQL, and they released a project called Data Loader, which is essentially a reference implementation for Node.js and how to effectively do kind of this caching and batching technique in a way that still looks like a normal implementation of just asking for something from your data source in a one-off. Like, I want this ID, I want this ID. But what it'll do on the back end is actually batch those up into a single request with caching and things like that. All right, so once we start looking deeper into serverless, and GraphQL, we come to this idea of, hey, what if our actual resolvers are doing different things, right? You can actually unify different data sources, for instance. I have one GraphQL endpoint, and I'm gonna go say, hey, you know what? I wanna hit a legacy API system. I want to hit a relational database system, and I want to hit a NoSQL system, right? You can actually do interesting things in your resolvers where, for instance, I had like the talk service and the speaker service. Those could exist in 2 completely different endpoints. One could be in our user management system or user database in a relational database, and our talks, for instance, might actually be in a NoSQL database. Your GraphQL endpoint itself that's running in a serverless function or things like that could actually talk to other smaller microservices running in their own Lambda functions and go have those actually fetch your data. Where this gets really interesting is for systems that you might have more compute-heavy operations that have to happen, and you want to spin those off into their own Lambda functions and not have to worry about blowing out all of the resources in your single Lambda function or your single function execution, but you want those systems to still operate quickly and efficiently and have more resources than just the one. So this is an interesting approach. It becomes more interesting with something else we're going to talk about in a little bit. But this is certainly a valid approach. Now, one thing I do have to bring up, so there's still these problems in the serverless world that we're all trying to solve. And that problem is traceability and debuggability. I don't know if any of you have worked with the serverless space or anything like that, but it's actually ridiculously hard to even just get like simple information out of these systems, let alone do something like this where my one request might blow out across 3 or 5 or 10 or a dozen more executions, and then try to figure out, okay, someone executed a request asking for something, and then I have no idea where it went. This is actively being worked on by all of the big providers. This is a really hard problem. But just know that you're going to sacrifice what you're normally used to in a server environment in terms of debuggability and traceability to go for an approach like this. It takes a lot of work and instrumentation. It's like essentially distributed tracing on a whole another scale. Okay, so I kind of alluded to another approach with complex resolvers and multiple data sources. But there's this new and opportunity in GraphQL and kind of this growing movement for something called Schema Stitching. So the folks at Apollo, who are doing a lot for the GraphQL community, essentially developed this idea of, you know what, I have all of these potential GraphQL APIs, these GraphQL endpoints. Why can't I do something to put them all behind one particular endpoint, right? So in this case, for instance, we have 2 GraphQL APIs. They're completely distinct from one another. We have, essentially, there's a universe API where you can actually ask for details about particular events that are going on at particular locations or things like that. And we have a weather API, right, where I can ask for, at a particular location, what does the weather look like, or what will it look like at a certain point in time? What's the forecast? So obviously, there's a connection between these two. You know, I would like to have the weather at the location of a particular event. So we can schema stitch these two APIs together, and we might get something that looks like this. Now, this is obviously kind of a naive implementation, right? Because when I ask for it, I'm saying, hey, I want an event of some ID that I somehow found, whether it's off some other listing or things like that is irrelevant. But I'm asking for the event in this query. Now, I'm also asking for, hey, somehow I happen to know that the location for this event is in San Francisco, so I actually want the weather for that particular location as well, right? So this is okay, great. We get like one less call. We kind of have a unified API. It's not optimal, and you kind of need knowledge ahead of time from the client side, so we can obviously do better. So what schema stitching, what we're working on and what people are working on, is this idea that I can create these systems independent of one another and then create and name my resolvers in such a way that I can resolve from one type in one schema of GraphQL to another type in another schema in another GraphQL endpoint. So essentially, once I link these two things together and the engine understands how to resolve across them with these remote executable schemas is what they're called, I can do something that's way, way more compelling. If we look at this, now all I have to do is say, hey, I want the information for an event of a particular ID is irrelevant. I want the title, the venue, but more importantly, at the location for this event, I want the weather that's going to be happening at this particular event, right? So suddenly we've gone through something where you have to have kind of this preconceived information about where this event's going to happen before I knew where the event's going to happen. And so making that request was really hard in the first place. Now it's become this system where your developer, the person using your stitched schema, doesn't even have to know that there's two schemas. They don't have to know that there's two endpoints behind this. So this gets actually really, really interesting. And what I'm really excited about this for is now I can kind of take the typical practices and learnings from microservices and apply them to GraphQL. Now I can have people experiment really quickly and build new services really quickly in GraphQL and provide these small chunks of functionality. And in doing so, in using GraphQL and in building these schemas, I create these really essentially standardized contracts for integrating together these various services through GraphQL. What we're starting to do and starting to work with folks on is how do we enable business units to produce things in GraphQL in such a way that it's valuable to them internally, it's valuable for them to consume their own services, but present them in such a way that other departments, other business units can look at these things and say, hey, you know what? Your weather service is great. It would match really well with my boat rental service, right? These distinct operations can start pulling and stitching these things together, forming entirely new products, extending products in ways that would traditionally not be very easy, and then presenting them to end clients in these seamless patterns. So that all said, it's really exciting. It's still a super new space. We're still trying to figure things out. So there's some words of warning that I would like to give all of you before you go running back. So my first word of advice, and I've learned this the hard way, is like, don't be this guy. I've tried to go to companies and say, hey, you know what, GraphQL, like literally everything, your life will be amazing. And then they're like, what do you mean REST APIs? We're still using SOAP. So yeah, if you try to do this kind of thing, it ends up being a lot more difficult than you would expect. And it gets really hard. So obviously, don't force it. Where I would not suggest doing this kind of thing and trying to implement this is a lot of this is common knowledge, right? If you have like non-problem legacy systems that are rarely used and you have no problems with them whatsoever, don't try to rewrite it in GraphQL, I should say. It's also not great for big data exports like a REST API, right? You don't want to like send like gigs or even tons of megs of data through it. Now, async returns are fine, right? That's a common practice. I want to get a report of something. I get back a URL or something that I can go check and eventually get my data. That's fine. More importantly, like any new technology, internal buy-in is key. If you have inertia against you, if people are building on REST and you actually have a solid microservice infrastructure on REST or with sidecars or things like that, yeah, you're going to have some momentum against you there. And so don't force it. Start small. Like start in your internal teams. Maybe get some of those small wins internally and evangelize based on those successes. Now, when it does come to non-problem and rarely used legacy systems, or you have other services that you depend on, other folks that you depend on, and their services, you can do some fun stuff where you can essentially wrap their REST API or their SOAP API or their system with GraphQL yourself internally and simply consume it with those your own kind of GraphQL wrapper around it. And in that way, you can kind of like just be sneaky about it, and they don't really have to know that you're doing that. But then your actual developers on your team can consume it in a more usable pattern, and you can kind of start sharing that out with other units. Like, hey, I kind of made their service, not be terrible to work with. You can be sneaky about it. Now, if you do something like that, or you have other downstream dependencies, you have to be a good citizen of your business. Whether it's serverless or GraphQL, or serverless GraphQL, you're really only as strong as your weakest resource, right? So if you have a typical relational or SQL database behind your serverless GraphQL engine, your serverless stuff can massively outscale any kind of relational database. You can, we've had situations where we turned on a serverless service and we're getting 10,000 requests per second. We don't flinch because it's serverless, whatever, it's fine. Now, if we had particular relational databases behind it or things that don't scale as well, obviously we're in trouble because we're only as strong as that one weakest resource. If you are playing with other folks, play nice. Things like queues, caching, all of that good stuff, you might have to put a little bit more thought into saying, I need to be nice to folks. I don't want to overrun those downstream systems. People won't appreciate it. They won't be happy for you that you have this massively scalable system that can take down theirs. They tend to not appreciate that. Some things that I didn't talk about a whole lot is kind of some of the basic stuff. And this is stuff that actually, while I say it's basics, becomes interesting to solve. How do I actually pass authorization down through my various GraphQL endpoints, right? So there's like this idea of a context in GraphQL that I talked about. And the implementations are kind of different between the language and reference implementations. And it differs between even organizations, whether you're using something like a JWT or other token approaches or things like that. It really depends on kind of the organization and how you've decided to approach that. So pagination is not a completely solved problem. There's the relay spec, which is a Facebook spec for how they handle pagination through GraphQL schemas and gateways. And then good documentation. So this is actually really important when you start playing the game of having lots of like essentially microservice GraphQL endpoints. Yes, you can have GraphQL kind of spit out this nice like autocomplete documentation, searchable documentation, but it ends up being that people want better examples. They're like, okay, so what's the actual right way to make this request for all of these speakers and talks, right? You want to provide ways that people can just go and kind of browse, I'd say, best practices or best implementations. So if you want to get started on this stuff, there's a few great resources and utilities out there. Dan Schaefer, someone that's worked very hard on the GraphQL stuff. He's part of Facebook. He actually talks about pagination and auth and some really interesting approaches. You can look that up on YouTube, Dan Schaefer. The Apollo stack, they're a great group of guys doing some really interesting stuff with GraphQL, providing actually metrics on GraphQL engines, providing really awesome clients that have like built-in client-side caching and schema stitching. GraphQL Schema cheat sheet, go look that up if you really want to understand the API and the types and things like that quickly. There's a serverless framework, so serverless.com GraphQL boilerplate, which essentially gives you kind of a look at here's how to build a GraphQL engine on AWS with things like DynamoDB and Lambda and things like that. And then GraphQL is actually a cool implementation of this kind of hybrid approach between functions as a service and GraphQL. And I would say if you were to start anywhere, go look at this. What they're doing is this idea that your resolvers and custom resolvers in GraphQL should by default be kind of like this hybrid approach where you can directly map to a function execution. They kind of take the complexity out of those multi-targeted resolvers and things like that and say, you know what? Like your resolver, if it's custom, is going to want to have a function behind it. And so they provide kind of a DSL for defining what a serverless GraphQL implementation could look like. So with that said, thank you. I hope you learned something, and it was certainly fun for me. And go play with serverless and GraphQL.